Hola, buenas tardes. Comenzamos el tercer webinar de esta edición del Astrofest en el 2020 y tenemos hoy a BABAK TAFRESHI con nosotros. Voy a hacer una breve introducción en inglés porque la sesión de hoy va a ser en inglés y luego haré la introducción de BABAK en español, pero muy brevemente. Good evening, everyone. We have the third webinar on this season, the Astrofest in 2020. And we have BABAK TAFRESHI with us. He's going to be talking about astrophotography. He is a National Geographic, very well-known National Geographic photographer. Also, the director of the TWAN. He's going to talk about TWAN a little bit himself, so I'll leave him to it. He's very well-known also in La Palma. I've been here, I don't know, more than 10 times. Comes once a year for the Astromaster. We are really glad to have him tonight. Bueno, pues BABAK es un fotógrafo del National Geographic, muy bien conocido aquí en la isla. Esta es la tercera edición del Astrofest que participa. Y viene cada año a la isla a hacer un workshop de astrofotografía. Es fotógrafo del National Geographic y de TWAN, y nos va a hablar de astrofotografía lo más sencillo posible para que aprendamos un poco y veamos también esas maravillosas fotos que él es capaz de hacer. Okay, Baba, you're all for you.
Thank you, Anna, and it's a pleasure to be a part of Astrofest La Palma, which is an annual astronomy festival by the island of La Palma, which I call it the stargazing paradise of Europe, and it truly is. You will see some examples of the images made from my almost annual visit to La Palma for the master class I do there. It's called Astromaster every year, usually in May. And next one would be in May 2021. I'd love to go back after the pandemic is under control. Let's talk about night sky photography, and this is not necessarily about midnight and astronomy, constellation, and so on. This type of photography, which is more often named as nightscape, could be also the beginning of the night, such as a few minutes after sunset to twilight, atmospheric phenomena, or just the landscape where the night sky is a part of the image but not the main subject. So we have very diverse spectrum of nightscape images that begins right after sunset. Here I am standing on the top edge of the caldera in La Palma. This is a large, massive volcanic caldera which is creating really stunning scenery from the peak of the 2,400 meters top of the island, where the observatory is located. And this is another astronomical importance of the island, where one of the world's leading observatories is right on the edge of this caldera. So I was there, Anna was next to me, we were doing our Astromaster workshop, and I was showing to the class that if you want to do a long exposure image right after sunset, how to use ND filter. So this class was a combination of any kind of nightscape photography and astrophotography as well. So this was about 20-second exposure where the ND filter helped to do the longer exposure. And a bit later, you have all kinds of astronomical and atmospheric phenomena to capture. So you will be very busy on a clear night right after sunset all the way to sunrise if you can continue with enough energy. This is, for example, still in twilight, and the sun is on the opposite horizon. It's actually the morning twilight in the Andes in Chile at 5,000 meters high. And it's a phenomena you don't need to be at such an exotic location to see. The foreground is very exotic and unique to the Andes, but not what is happening in the sky. That blue band, it's called the Earth's shadow, and it's happening twice every 24 hours. In fact, once after sunset and once before sunrise. You have to look to the opposite horizon of where the sun is located. And as it's going below the horizon or just before rising, you will see the actual shadow of our planet casting over the atmosphere. And it's blue, and it's really eye-catching, especially when you have very transparent air and clear horizon. Say, for example, you're on the ocean front on a very clear day, or you're on top of a mountain like here, and then you will see it very prominently. Most people miss this because they're not aware of what they're looking at, and it could be very diffuse if you don't have a perfect condition. But look for it the next time. Now it's a bit later, the twilight is fading away, and the Milky Way is glowing in its most spectacular form above the caldera in La Palma. On the right side, you see where the observatory is located. The high clouds are still shining in red into the camera, although they're colorless to the eye. So some of these colors are already gone to the naked eye because our eyes are almost color blinded at nighttime. I will give you more examples about this later on, but the human eyes is not able to detect light of any diffuse low light objects such as the Milky Way or those faint clouds at the moment, but the camera is able to record that in a long exposure. So that's the difference between what you see and what the camera is able to see. However, the Milky Way is still stunningly visible to the eye, although colorless from such a location. This is one of the world's best locations for stargazing for obvious reason you see in this picture. And the Milky Way, it has the view in September where you see the galactic core standing above the southwest right after sunset. So anytime from March, April to September, October is the Milky Way season in where you can see it either later in the night. In March, April, it's rising after midnight, or you can see it at the beginning of the night in August, September, and October. But then in November, December, and until the end of winter in the northern hemisphere, you don't see the galactic bulge of the galaxy from unless you're located somewhere south, and then or tropical areas, you may see just at the beginning of the night, for example in November. But otherwise you will miss that part. However, for every season there are other attractions for a night sky photographer. For winter time, currently we have one of the best meteor showers happening. One is right now the Leonids, which is peaking, although every year November 17 and 18, but it's really a major show every 3 decades when the stream is really rich with a new approach of the comet, the Tempel-Tuttle comet, which is responsible for Leonid meteor shower. So we are still far from that. But on average, the best meteor shower of the year is Geminids. Most people have heard about the Perseids in August, but the best one in number of counts, especially for Northern Hemisphere, is Geminids in December 14, between 13 to 15, and this year is on the morning of 14, and moon is not a major part of the night, so it would be a great opportunity this year if you want to plan something ahead of time. It's less than 1 month from now. So yeah, winter time, you also have the opportunity to see some of the brightest stars and most prominent constellations in the night sky, such as Taurus or Orion or Gemini. So for every season, there is an opportunity for you. Let's continue here. As the twilight is fading away, we come to a complete darkness. Now your foreground has a very fading shade of gray, or you can use it as a silhouette against the brighter sky and a long exposure image like this. I will talk about the numbers later on in the webinar. This is about 15 seconds of exposure. Most of my images are single exposure photography. I do not practice blending or other types of composites, but on few cases which composite photography is used, I will clarify and explain about that. Otherwise, most images are single exposure or a panorama of fixed single exposures stitched together to get a wider angle, higher resolution image for print. This is just a single exposure out of a time-lapse sequence. The reason you see such a clear view of the Milky Way is behind 3 main things. One is the site, is the location. This is a pretty good dark sky location in Atacama Desert of Chile. It's called Cerro Paranal, where these giant telescopes are located. and they work together as part of an array called Very Large Telescope. Second is the exposure. The exposure and the ISO sensitivity of the camera is high. The exposure is max to 15-20 seconds. More than that, you start to see the trailing the stars due to the Earth rotation. I will talk about your limit of exposure later as well. And the third is the lens. So location, free of light pollution, high altitude. Second, exposure and ISO. And third, sometimes the most important, is a fast wide-angle lens that you can open up the aperture to f2.8 or better. This was at f2. So this fast aperture lens enables me to overcome the limit of the exposure, which is due because of the Earth rotation. Sometimes you illuminate the foreground because otherwise the silhouette does not show it well. It has a lot of details you like to reveal. You have to be careful on how much illumination and how uniformly you're going to do that. Otherwise, the image looks artificial. This is Yellowstone National Park, and the hot spring is illuminated by a portable small LED panel. I tried to move during the 15 seconds of exposure to uniformly illuminate that in a color temperature similar to daytime. And above is the Milky Way with brightest star, the orange one, Antares, right on the top on the edge of the hot spring. Sometimes the illumination is coming from the sky and the source is the moon. In fact, this is the best source of illumination to get natural looking landscape at nighttime. But what is the best phase of the moon in order to capture everything naturally and the sky is not totally vanished by bright moonlight? If you shoot under full moon, you realize there is no way to reveal a starry sky. But if you select a lower phase of the moon, such as first and last quarter, where the moon is 50% phase, half of the moon is illuminated, then you get a similar picture like this one I did. Just as a side note, I have applied a diffuser filter on front of the lens for this image. That's why the stars are a bit diffused and more colorful. The reason I do that, I use these diffuser filters, is more for educational purposes. It shows the constellations in the sky much better than a no diffuse image, because then of course it would be sharper without the diffuser, but the balance between the two, it works the best. For example, instead of using the diffuser for the whole amount of exposure, use a larger square diffuser, which you can hold it by your hand in front of the lens only for a fraction of the exposure. So that's one trick you can try. Or if you don't like this diffuse popped out stars, just shoot it without that. It's a personal taste. It helps to reveal more colors because the pixels which are receiving these lights from the stars are not saturated. When you use a diffuser, the light is scattered to several pixels instead of one, and then the pixels are able to retain and show the colors. And also they show the diversity of brightness of the stars, more like what you see in the night sky with your own eye, where the Betelgeuse, for example, the orange star right there, is brighter than the belt of Orion. If you're looking at Orion in the middle of the picture, you realize this is very odd looking way of this constellation because it's upside down. That's the way we see the constellations from the southern hemisphere. Back to the illumination point, if you use a fainter phase of the moon, such as 20% crescent moon, then the sky would be much more brilliant with the stars and the Milky Way will be visible, but then the illumination in the foreground would be less. It also depends on how much albedo has the foreground. If it's very white, then the albedo is higher. That means reflectivity is higher. So you can either use a higher ISO or even less illuminating moon, just a crescent moon, and still the foreground would be visible. If it's very dark, then you need a stronger moonlight to illuminate that. Continuing with moonlight, now we are in another night of La Palma during my annual class, Astromaster. And this is, instead of the top of the mountain, we are in one of the pine forests. These are ancient pines in the island, responsible for a lot of water, in fact, that is captured by the trees and sent through the ground, and the island is dependent on that as well. So it's a very interesting ecological cycle in La Palma. But from the point of view of photography, this is a 10-second exposure with a 24mm lens, and my subject in the night sky is the brightest star in the entire night sky of planet Earth. It's not as bright as planet Venus or Jupiter or Mars when it's close to us, right? These nights, for example. But as a star, this is the brightest one, called Sirius, and it's visible mainly in winter nights. On the horizon is the second brightest star in the Earth night sky, Canopus, which is a southern star. That's why you don't see it very high in the sky from this latitude of about 30 degrees. La Palma is 28 degrees. You see a neighboring island on the horizon, and everything is just uniformly illuminated by the moon. A side note is that the night sky is only naturally blue only when there is moon or twilight in action. Otherwise, if you come up with a blue night sky in your image, when there was no moon, no twilight, it's the fault of white balance. That means you have changed the white balance too much towards the colder temperatures on the menu you have, either in the camera or in post-processing, like to 3000, 2000, and then you get to see a blue sky. It's more perhaps pleasing to the eye to many photographers, but it's not the natural color of the night sky. If you're always changing that temperature to 2000, 3000, anything under 4000, you're changing the natural color of the night sky, and that will change the color of the stars, that will change the natural color of the Milky Way. And from documentary point of view, it's a mistake. From artistic point of view, of course, you're open in photography to anything. You can change the and alter the nature of anything in photography as part of an art, but you don't call it documentary nature photography anymore. It's becoming a digital art. So be careful with that if you are playing around with white balance. For example, this is white balance of 4800, almost 5000. So this is near the daytime white balance we use generally, and the Milky Way is visible just before it's setting above the Southern Ocean on the southern coast of Victoria, Australia, the Great Ocean Road. Illumination in the foreground comes from two things. One is just a starlight, and the second is something called the sky glow. A sky glow is a combination of atmospheric phenomena in the upper edge of our atmosphere called air glow, which is always there, sometimes more, sometimes less. And also the rest of the sky glow could come from light pollution on the horizon that scatters around here. So this is the way you reveal even very dark nights. You can reveal the foreground if you're using a very fast lens. This is a panorama, a stitch panorama of 6 shots. Sometimes illumination is from a transient phenomena, but not in every place. In places near the Arctic and Antarctic where aurora borealis is active and visible, then you can even get illumination in the sky and on the foreground from this light. This was in Iceland, exposure of about 10 seconds. It was not a very bright aurora. That's why I could capture the aurora and the starry sky at the same time. If it's brighter than this, then you have to reduce the exposure in order to control that. It's the end of the twilight in Guatemala on the tropic, and these are typical towering cumulus clouds in the tropical area. But in the night sky, something strange and interesting is happening. Planets Venus and Jupiter, the two brightest planets in the Earth sky, are coming together. It's a telephoto image through 135mm lens, and beyond Venus and Jupiter in our solar system, another object almost 5,000 light years away is aligned with the two. It's called the Lagoon Nebula. It's part of the Milky Way galaxy, one of the giant nebulosity in our galaxy. All of these in a single exposure of only 4 or 5 seconds. And it's part of a time-lapse video. In fact, it's one frame of this. I released this as a clip. You can look on my website or social media. It's called Celestial, with very elegant music by BABAK TAFRESHI. Now we are in Iran, the country I come from. I'm based in Boston, lived in Germany for several years, but I'm born and raised in Iran. And I have started my night sky photography in Iran, passion to astronomy when I was a teenager. And the country had so many high altitude and remote deserts gave me an opportunity to capture starry skies in many locations. But like many other places in the world, light pollution is growing in Iran, US, Europe, and everywhere. So we have to be active against that as well, which is the end part of my webinar, and I will talk about it here in a night of March, where is the beginning, usually the beginning of the Milky Way season. The galactic band is rising above the desert. I have illuminated the desert with the LED panel and torch, and up in the sky, the summer triangle is rising. It's a panorama. But let's talk about definition of nightscape photography a bit. So it's anything from cityscapes to architectural wonders at nighttime, natural landmarks at nighttime, not necessarily about astronomy, but could include the night sky at a certain time where, or certain configuration where educators and science journalists and people who communicate science with people can use it as a resource for education. Then it becomes an astrophoto. It could be made at a time and location that records a special phenomena such as meteor shower, comet, or eclipse or conjunction. Then it becomes also an astrophoto. And it's a part of nature photography. So it's based on realistic documentation of nature. That means I do not multiply stars here. I do not add the moon from another horizon to over here. I do not remove part of the picture. I do not copy Milky Way from one location to image from another location. I do not blend images of daytime and nighttime. These are rules of documentary nature photography in photojournalism in general. But if you're doing it for the purpose of art and you like to release it as digital art and be very clear and honest with your audience, of course, photography is not limited to anything. But if you do what I usually present, documentary of nature, then you're limited with realistic photography. That's why I'm not really a great fan of double exposures in night photography, where you add moon from one side of the sky to the other one. You know, moon is like any other elements of the night sky, any other elements of nature. For example, it could be a lion in the wild. You do not double expose lion on top of an elephant in the wild. You know, that's obviously fake. But if you do that with the moon and night sky, most people don't realize it, so they accept it. And you may accept it too, because you think moon is part of decoration in the image. It's not really an essential element of nature. But that's not right. You know, night sky is part of our nature, and we respect it in the same way in documentary photography. Another part I like to emphasize is the connection with the foreground and the story behind. You have to be very careful on selecting the foreground that completes the story you like to share with your audience, because nowadays photography, beyond art and technique, has also the value of a moment and a story. And this has been always 4 essential elements of photography, but it's very critical nowadays because people are saturated with the amount of images and beautiful eye candies they see on social media, but they lack the moment and the story sometimes. So you have to implement that in your photography in order to have a powerful, impactful work to share with public. So the story here was about ancient, prehistoric petroglyph in central Iran back from almost Ice Age. Some of them are about the Ice Age time, according to animals appeared here. So almost 17,000, 20,000 years old. And then there are layers of different civilizations all the way to 5,000, 6,000 years old when these horse riders appeared in the Middle East. And some of these figures are related to the night sky, probably. And the constellation behind completes that. Another part of the story is to talk about the difference between this type of night sky photography and photography based on telescopes, which is the main part of astrophotography, is using telescopes. This type of wide-angle astrophotography or nightscapes, they present the night sky often as you see with your own eyes, from the angle point of view, not from how deep they are. For example, this image from an island in the state of Rio. It's called Ilha Grande, and this island has 90% protected area, so it's very little light polluted, and the sky is stunningly beautiful when it's clear. So you look around, you look above these coconut palm trees in the forest, and the Milky Way is just stunningly visible. But this image beyonds the human eyes because it shows the colors, and it shows more background stars than the human eye can see. So there is a difference, but however, there are some similarities with these images and what you can see, especially from the angle point of view, the amount of structure and details in the Milky Way, and the brighter stars. You will see the color of that bright star with your own eye as well, which is called Antares, in the heart of a scorpion. These images, they connect people to astronomy and night sky because they show wide angle images. They have a reference in the foreground people can relate to, and they're unique based on location, sky events, and light situation. That gives them more power in the art because they cannot be replicated easily. And they usually have less post-processing than deep sky photography, which is based on stacking a lot of exposures. When you shoot through a telescope, you collect data through many hours and many exposures, sometimes many nights. But here you're based on single exposure, few exposures, so it's much less processing involved. But they lack serious scientific data. You're not going to discover something here unless this accidentally happens, especially in atmospheric phenomena. And they're not aimed to resolve very small details of celestial objects because you're often not using a telephoto lens. I do use sometimes telephoto lenses in nightscape photography, which I gave you some examples before, and I will point to that later on as well. Here is the setup. So the setup, it could be very simple. You know, it's just a camera tripod and a remote cable to control the shutter. You have this intervalometer inside the camera in most cases as well, but I use an external one because it allows me to not touch the camera, to not just mistakenly change the frame or shake the camera during the exposure. So that's a benefit you're going to have if you have an external intervalometer attached to the camera. And then, although the setup is easy, you have to move from one location to the other, and it's adventurous because you don't see where you're walking at nighttime. So you have to be careful with that. Use a red light when it's possible because it gives your eyes more dark adapted vision. You can see around much better. For those of you who are using a very strong white blue light at nighttime in order to safely see things, that's not really a great option. A yellow light, softer light, lets you to see both shadows and illuminated areas much better than a very white blue light, because that only shows you the illuminated area. The shadows becomes really dark, and the eye is not adapted to the darkness. So it's a point you might want to consider later on in the next opportunity at nighttime. In comparison to deep sky photography using telescope, the setup is very different. Here you are based on one location the entire night. You're not going to move because the polar alignment of the telescope will be changed. and it's not easy to move this setup. While here, you're going to move from one shot to the other because you're going to change the foreground, and it's very easy to do that. The foreground and the field of view is different too. For example, here on the left side, you're looking at the field of view similar to the human eyes, a 28mm lens, for example, and it shows you Orion and Sirius rising. That marked square is about 1 degree, and that's the field of view of a telescope. So the telescope, when pointed towards this field of view, is only seeing the Orion Nebula, and it fills the entire image. While in wide-angle image, the Orion Nebula is just a tiny dot, a blurry star somewhere in the picture. These two together can complete the spectrum that people need in order to understand and relate to the night sky. The right side image, although very colorful to most people, is just an abstract art. It doesn't make sense. They cannot understand the scale of it or the location of it in the night sky. But when you combine these two together, they can speak completely and make the spectrum fully understandable of the size of the object in the night sky and what the telescope can resolve. Another example with the solar eclipse, 7 images are captured in a time-lapse sequence, are put together in this multi-exposure image at top. And at the same moment, my second camera was my hand. I was doing a handheld panorama during this total solar eclipse of 2008 in Siberia. So that gives you a very wide-angle image of the eclipse and a very close-up view of the solar corona and the details. Now let's talk about the numbers. I call them the golden numbers of nightscape photography. It's 20-second exposure, ISO 3200, and f2.8. You play around these 3 numbers and then you make all kinds of nightscape photography. So technically speaking, nightscape photography is not difficult. The challenge is to get used to the dark environment at nighttime, know the night sky a bit, highly recommend that, and at the same time to handle the nighttime light, to know what is coming after 10-20-second exposure, how much light you need to illuminate the foreground. So this is coming by the experience and some knowledge. The range that we use is 10 to 30 seconds, depending on the lens. The wider angle lens, you can expand the exposure mid, and the higher focal length, you're limited to shorter exposures. ISO depends on how good the camera is performing in low light. If the camera is low noise and the night is cold, remember that. In a very cold night, your camera can perform much better in high ISOs. It's less noisy. And also, if the camera is newer with better sensors, if the camera is full frame, has usually less noise. If the camera has lower megapixel numbers, such as in the range of 10, 20, 30, compared to 40, 50 megapixel, they're less noisy because the individual pixel of the sensor is larger. And those large pixel size, meaning lower megapixel camera, are usually less noisy and more sensitive to noise. And also it's about how much ISO you need. Sometimes the night is not that dark. For example, here I had illumination from Aurora in Iceland with my colleague during our annual photo tour in Iceland, and exposure was only 2-3 seconds, in fact, otherwise the foreground would be blurred. And I didn't need a very high ISO because it was bright enough thanks to the aurora. When you don't need the high ISO, it's better to reduce it because then you have a better result, a more dynamic range image at the end. When you're shooting at lower ISO, not only it's less noisy, you also get more dynamic range to recover shadows and highlights in post-processing, to show more natural colors. So these are also related to the ISO you're using. But sometimes you have no other option other than expanding to the highest ISO, which is still workable, is still acceptable in noise. And sometimes, you know, the limit is because of the foreground. You have a foreground which is very close to you, so you have to use a higher aperture. Instead of 2.8, you have to use 4 or 5.6 in order to get higher depth of field. Then you have no other option than increasing exposure, increasing ISO in order to get that depth of field. Or you can go towards composite photography and blends various focus. So one image at a closer focus, another image at medium focus, another one for infinity, and then combine them in a composite using a software, or many software like Helix can do that, commonly used in macro photography. But if you want to do it in a single exposure, then it comes the question of hyperfocal distance. Look for it online, and there is a table of hyperfocal distance that gives you all the numbers based on the lens you use, based on the focal length you have, and the object distance. If you want to shoot with a 14mm lens, for example, on a full frame camera at 2.8, which is a very commonly used aperture, then any object at about 10 feet and beyond becomes almost in focus with the stars, with the infinity. So you can just set it on infinity, set the focus on infinity, and do not worry about objects that are beyond 10 feet or 3 meters. They're almost in focus. If you want to be more careful with that, you can focus somewhere between the two. And if the subject is very important and illuminated, then you can focus on the subject itself. Single exposure or blending would be your choice. My choice is usually single exposure and practicing all the school photography techniques, which is not really enough time to explain all of that in this 1 hour webinar. But if you like, I have more resources on my website, and about 10 other webinars you can look on my website for details on every subject. And then comes about the maximum exposure you can do. It depends on the focal length. Classically, it was called the 500 rule, 500 divided by f. Nowadays, we're using higher megapixel cameras, so I have changed this to 300 in my presentations. Give you an example. On 14mm lens, it would be 20-second exposure. On 300 telephoto, it's only 1 second. And if you're using a crop sensor, multiply that focal length f number by the crop factor of the camera. In many cameras, it's about 1.5, but in some others, it's 2 or even more. So check that with the camera you have and calculate the amount of exposure you can do. The maximum exposure is also related to where the object is located in the night sky. It's very close to the celestial pole, like near Polaris. You can expand exposure to much more, and still the object is in pinpoint. And if it's on the equator, you follow this rule, because this is rule for the celestial equator, where the most amount of motion is visible due to the Earth's rotation. Here's an example of these rotations and the amount. When you're looking near Polaris on the top right side of the picture, the rotation is much less. This is angular rotation of the objects in the sky due to the Earth rotation. And on the left, as we get away from the celestial pole, the rotation angle is still the same, but the amount of rotation is much more. So that means the object will move faster in your field of view compared to the object to the star, which is next to Polaris, for example. So speaking of the image itself, this is one of the World Heritage Sites in Iran near Persepolis, the tombs of ancient Persian kings from 2,500 years ago, illuminated by a road and moonlight at the same time. Exposure is about 1 hour. I guess it was from 2007. And in 1 hour exposure, I didn't use a single long 1 hour shot, because otherwise the digital camera would be very noisy and hot. The sensor would be too hot to create this image cleanly. So my only chance with the digital camera in 1 hour would be to split it to shorter exposures, 61 minutes, for example, or 120 shots each 30 seconds. Then you have a result of a video, a time-lapse video, or you can stack them all together in a free software such as Star Stacks with X at the end, and create this one. I also have a dedicated webinar on star trails. You can look it up on my website. But compare it to here. These are single exposure images on film, and each is about 3-4 hours in a pretty dark night sky somewhere in Iran. From the time I was still shooting film. The right side is by my colleague Oshin Zakarian, and look at that really marvelous image by Oshin. It's on medium format film camera, and each star has its own color in constellation Orion. Still today, with digital cameras, we're not able to reveal these elegant colors in long exposure star trails. So that's an advantage that the film camera still has in long exposure. If you have one of these in your garage, give it a try. With a low speed film in somewhere very dark, and you will be surprised with the result. Compare it with this one in La Palma. I tried to preserve the star colors in this image using a lower ISO and increasing vibrance in post-processing. Then I can see some of the colors, but still, if you compare it with how much natural looking this film image is, that's the true power of a single exposure long images like 3-4 hours. Nowadays, I sometimes do single exposure with digital cameras, such as my Nikon D850 at ISO 6400, or the Canon EOS RA I use at base ISO 100. I can go up to 40 minutes, 45 minutes, and the sensor is still not too hot, especially in a cold night. So the image is not that noisy. So you can try that as well, and you will see the difference between a stack star trail or a single exposure star trail, how it looks. The benefit, of course, of doing a stack is that you also have individual frames with pinpoint stars. You also have the possibility of creating video. Now let's talk about the sources of light. We have many sources at nighttime, starting from twilight, then comes moon, then comes artificial light, and all these important ones are visible in this image. In fact, the twilight is almost gone, but the moon is shining on the image, and it's illuminating the foreground, illuminating the sky. That's why the background sky is bluish. Then comes the artificial light from two different sources. One is a road cutting through the Alborz Mountains of Iran from Tehran to Caspian Sea, and the other one is a city on the far horizon glowing, creating that glow and illuminating the clouds. It was back in 2007, and this specific image really convinced me to completely shift from film to digital. Finally, after several years of struggle between the two, I finally shifted to digital with this image. Starlight and the Milky Way could be the result, contribute to illumination, as I showed you in that picture from Australia, if you remember. And then zodiac light, probably have one example of that in the presentation. It's the glow coming from asteroid dust in the solar system, only visible from dark sky locations, aurora, and air glow, which I will explain later on. Nightscape is really handling the art of handling all these ambient lights. A typical question I receive on social media is this image visible to the human eye? I pointed to that at the beginning. Let's repeat. We don't see the colors at nighttime. If you were standing next to me in Grand Teton National Park of Wyoming in this summer night, you would see almost like this. So the Milky Way is still stunningly visible. A bright star Antares is showing its color. The rest of the things are colorless, because that's the ability of our eyes. But these colors are real and are there. You can enhance them a bit in post-processing, and they have they're representing physical character of each star and galaxy you're looking at. But you can also make mistakes in natural color of night sky. This was an experiment I did more than 10 years ago with a modified camera. I released these two on social media in order to see the reaction from the public. And most people went for the right side image, where the sky is more dramatic, blue and purple, but this is totally fake image. from color point of view. And if you change the white balance and tint inside the camera or in post-processing, you can easily get blue Milky Way, purple Milky Way, and this was not at the time of strong twilight. It was near the morning, but twilight was just beginning. So sky should be to the left, similar to the left. This is almost black with a little bit of green due to the air glow, and this is the natural color of the Milky Way. The color on the right side reminds me of all the images I see sometimes on social media. People share Milky Way in all colors of the spectrum. Our galaxy doesn't change the color every night. It's a matter of our post-processing. And if you don't change the color of an elephant in wildlife photography to red or anything exotic, you don't change the color of the Milky Way either, as an essential element of nature. Some examples of very natural looking Milky Way colors by Akira Fuji, very inspiring Japanese photographer, did all these images on film. And now back to our topic. Here is my colleague Oshin Zakarian, another the World at Night photographer. Looking at the Milky Way, I've illuminated him and used a higher aperture in order to have him and the background both in focus. Let's talk about the lenses. Very common lens is a 14mm at nighttime. It could be prime or zoom. If you're using a zoom, better to use very short range zoom lenses, such as 14-24, 15 to 30, 16-35. These are lenses which are very common for landscape photography in daytime, but also pretty useful at nighttime for time lapse as well. Perhaps 14-24 is the most popular lens. But for those who are really looking for deeper images at nighttime, they go with something like 1.8 by Sigma or 21.4. And then this comes the popular lenses. One step higher, you start to resolve more things at nighttime, 28 or 35, even 50 and 85. These are prime lenses. And one of my favorite is 135, 1.8. On the other side, going to wider angle like fisheye 8mm, you can capture the entire sky in a full frame camera for phenomena such as aurora or meteor shower, or creating very unique perspectives. Crop sensor for the same equivalent field of view would be these. And favorite combinations, if you want just two lenses, for example, this is probably the most commonly combination of lenses for both daytime and nighttime landscape photographers. But other options are there too. For example, if you like really fast lenses, go with 14 and 50 plus one zoom for close-ups of moonrise, moonsets, some deep sky objects, a comet in the sky, and any kind of elementary deep sky photography. Examples with very fast lenses. This is 35mm Sigma at 1.2, completely wide open aperture, reveals objects which are usually visible only in deep sky photography. Because the lens is very fast, the camera is sensitive. Compare these three images. This is with a panorama with 24, so it's equivalent to the human eye field of view. Then we go deeper with 85 single exposure. Now you're looking at Antares and the head of a scorpion. Some deep sky objects are starting to become visible. This was the same area of the sky from my annual summer workshop in California. I was showing this to the class, that what could be achieved in single exposure of 15 seconds. And it's really striking to me that this is achievable with today's technology. It was with Nikon D810A, which is a modified astrophotography camera by the company. We also have the Canon EOS RA made for astrophotography, which was released just a few months ago. It's about a year that is available now. Or you can modify your own camera. I only recommend astro modification of the camera, meaning removing one of the layers in front of the sensor, one of the filters related to IR cut. only when you're doing deep sky photography. For nightscape photography, it's not really that necessary. But if you're doing more of these nebulosity and Milky Way subjects with telephoto lenses, you will see a big difference when the camera is modified. Like this 15 seconds showing many nebulosity in a single exposure. But I have also used a tracking mount, which will be shown in the next slide after this one. This is from La Palma, now winter sky, Orion Nebula, another 15 seconds, 2.8, 135 millimeter lens. So the trick is using not only a fast lens and very sensitive camera, but also very dark location, plus a tracking mount like this one, Polari by Wixon, very compact, comes between the camera and camera head. So there is one tripod head underneath and one above it in order to level the horizon. And then you polar align it with Polaris, for example, in northern hemisphere through that hole, very simple and easy. And in the southern hemisphere, it's a bit more challenging. We don't have any polar star like in the north. After your polar line, you can go as long as the tracking accuracy allows, but you're also limited to the Earth rotation. If you go very much beyond that limit, like 3-4 times that usual time, that gives you resulted from the 300 by F formula I shared with you. If you go 4 or 5 times above that, you will see that the foreground is completely blurred. But if you just go a couple of times above it, then you will see the difference of how much more data you receive, and also the foreground is still not bad. It's okay. These are just deep sky images with telephoto lenses. As we are getting a bit late in the time we have, I like to mention a few things about the project I'm doing, The World at Night. You will find it on web and also on social media by these accounts, Twanite. We're a group of 40 people in 25 countries doing this nonprofit initiative together in order to inform people about the importance of preserving the night sky, importance of preserving natural night environment of our planet against light pollution. And also it has a peace message that we are all under one sky. Regardless of what culture and religion you have, you are sharing the same sky. And this perhaps is a bridge to more unifying nations under the single roof of eternal roof of night sky. Nepal, Himalayas. And then comes to another message of the World at Night project, that there is plenty to reveal at night time. You know, people are usually less comfortable with dark environment, and that comes from our region. We're not nocturnal species, so we are not really comfortable in low light and darkness, but there are plenty to discover and explore at nighttime. The beauty of nature, the sounds of nature at nighttime, and your loneliness with the whole galaxy above you, it gives you a new perspective to life. And that's one of the chapters of the book, The World at Night. This book is not about how to do night sky photography. I have a little chapter at the end of it about to do it, but it's more about the stories of the images, the locations and the places you can do night sky photography. So it would be a good combinations with your knowledge of night sky photography and having this book to know where to go, how to do things, and what are the examples of these images made by the World at Night team in different countries. The book is also available in other languages, in German, Japanese, and French. I also started a web page on my website about dark sky places, where you can find all the maps and guideline in order to find these dark sky places. But more important, you will learn that we as night sky photographers have responsibility to protect the night sky for us and future generations. and it's a major challenge and issue because light pollution is growing everywhere. And we don't know how to use light properly. In many places, we just send the light to the horizon sky, sometimes for commercial purposes, sometimes we're careless, and sometimes it's an icon of a city. Here in Dubai, for example, it was much light that didn't let me to reveal any stars in the picture other than moon, a couple of bright ones. And this is the same condition in many other cities. However, even inside the cities, you still have opportunities to photograph the night sky and share stories with people, like doing this from a city and somewhere nearby the city. This is Tehran, and about 60-70 kilometers away, about 50 miles away from it, I'm shooting the same field of view, same orientation almost, and you're expecting to see the above picture and the below one if there was no light. Of course, we're not going to have that in modern world, but we can reduce that amount of light that we are just carelessly sent to the sky. And it's not only a matter of astronomers, it's not only about night sky photographers. The reason I'm emphasizing on the issue of light pollution is that it's affecting human body as well. It's affecting many species. There are over, according to the International Dark Sky Association, more than 4 billion birds might die because of light pollution every year, because their migration paths change to the cities, they're lost and die there. And we are talking about a major environmental impact created by light, especially the new white-blue LEDs, which are becoming popular in many countries as street lights. So be careful about that. Talk to your relatives and friends about this issue. And be informed yourself of what is happening with the light pollution. This is an article we did for National Geographic website. It's very comprehensive, so I highly recommend you to have a look. You can find it either on my website, babaktafreshi.com/media, or just simply Google Nat Geo light pollution in order to find it. And then you will read that how white blue LEDs are affecting human body, and it's related to two kinds of cancer, in fact, as one of the contributors for those people who are shift workers or under very strong light near the bedtime. So this is obviously altering our circadian cycle by changing the amount of melatonin in the body. So it's a major issue, and American Medical Association officially announced that in 2016 that white blue light and high exposure to that at nighttime is affecting human body in a major way. So this is something that our generation needs to deal with it. And there are many places who use these lights for commercial purposes. This one is a casino and hotel, Luxor in Las Vegas, sending this massive blue rays to the sky every night in the past 30 years or so. In the picture, you see a bat flying through. There are hundreds of these animals next to this light because they're attracted by the light, amount of insects captured by the light. So it has created its own ecosystem, deadly ecosystem for these animals. Thank you for listening. You can reach me over social media on the website if you have any questions in future. Anna, I'm not sure if we have time for many questions to answer, or if there is any questions by the audience.
There is a couple of questions, so I think you can show the videos that you have.
Yeah, sure. Showing what?
I thought you had a couple of videos if you want to show them now, because we don't have that many questions, but if people want to,
okay. Yeah, well,
send us the questions so they can have a couple of more minutes.
Yeah, sure. Well, I have passed through some of the slides, in fact, because I thought we don't have enough time, so I can finish that part. And it was more about using telephoto lenses, examples of these telephoto lenses. It's good that we have a few minutes to complete that. So I was talking about lenses in the range of 50 millimeter and above, using a star tracker. When you are shooting at higher focal lengths, such as 50, 100, and you use that formula the 300 rule. If you divide 300 by a focal length of 100, your maximum exposure is only 3 seconds. In 3 seconds, you cannot really reveal many details of deep sky. That's why when you go to higher focal lengths, use of a star tracker is necessary. It could be a very portable one like Polari, or it could be something that you can attach a telescope to it, or a long telephoto lens for some serious deep sky photography revealing galaxies and so on. But these examples are with simple telephoto lenses, although they're very fast. But speaking of focal lengths, they're just in the range of 100 to 200. This is with 100. North America Nebula. I use a modified camera. You can capture this nebulosity with a regular camera too, but the exposure would be 3, 4, or 5 times longer because regular cameras are cutting the red end of the spectrum where these nebulosities are shining. We call it the H alpha band. And due to their IR cut filter, we lose most of the light coming from this nebulosity at the red end. If you want to capture it, you have to remove that IR cut filter from the sensor and replace it by another one which cuts after the H alpha region. It's a very minor change, but completely changed the response of the camera to astronomical objects. Another example with 100 millimeter nebula is visible at top, and a bright meteor is captured in this small field of view above the Sierra Mountains in California. With a 135 millimeter, the recent comet Neowise, it's a single exposure of 2 minutes. The lens and the camera was on a star tracker for this 2 minutes. It was aligned and then post-process in order to reveal more of the 2 tails of the comet. This was a pretty nice comet we had. Every few years there's one of these naked eye comets. We couldn't say it was a great comet because the great comet is visually really stunning to the eye, a naked eye, but this was on the range of becoming a great comet. But still it was very photogenic to the camera. This video shows me using a 150 to 600 telephoto lens on a larger star tracking system, which allows me to attach a telescope or a lens of this size. And on that night in Maine, in northeastern US, we had our annual astronomy retreat program. It's a typical star party. So regardless of where you're located in the world, look for your local astronomy club, and they usually have monthly or seasonally star parties. And join one of these because you have access to dark sites, you have access to knowledgeable people to ask questions, and you join a group which are all passionate about the night sky. It's a lot of fun. And here is a result of that night. For example, this is with a 200 millimeter focal length, a stack of number of shots. It was not a single exposure. Total exposure was 30 minutes. It's the area next to bright star Antares in a Scorpion, visible in the summer night. And there's a globular cluster on the right side and all these dust in the galaxy on the left side. This is a galaxy in our neighboring universal neighborhood. We call it the local cloud, the local group. It has a few major galaxies. Milky Way is one of them, Andromeda is another one, and M33 is another local group. Major galaxy spiral, which is easy to resolve its arms, even with a telephoto lens. I was shooting at 600 millimeter, and this is visible on these nights. It's best visible in the autumn, so you can give it a try in the next imaging session you have under rather dark sky. This one needs a bit more darker sky because it's very diffuse. It's known as Helix Nebula. So I can list more than 100 objects easily for just a telephoto lens to do deep sky photography. So if you're thinking about astrophotography needs very sophisticated telescopes and equipment, this is not true. If you want to just start and enjoy capturing these objects even with single exposures, just need a tracking mount and a telephoto lens. After you have accomplished a lot of things, you can decide if you want to move to upper level of deep sky photography with a larger telescope or continue with wide angle images. So you don't need to invest at the beginning on a lot of things. And then last slide, I'd like to just finish it again with the numbers I shared at the beginning. So the golden numbers are 20 seconds, ISO 3200, 2.8, and range, the common range, depending on the subjects you're shooting, the performance of the camera, how close is the foreground in order to have it in focus with the stars. So you will decide based on that. And I will finish it with my contacts again if you want to have more information, some of the images and the projects I do. So Anna, if there is no question, I'm happy to finish.
There's plenty of questions now. I think it was good that we gave a couple of minutes to people to ask a few questions. So one of the questions was the golden numbers again. So you've just mentioned them and repeat them. So that's one question gone. Most of the questions are about your preferences. Mirrorless or Canon, Nikon, and also programs for post-processing. What is your preference for that?
Well, you know, a few years ago, if you were asking this, there were more DSLR cameras that were favorable for low light photography and night sky than mirrorless. Like 5-6 years ago, it was only Sony A7S, which we were recommending for low light photography and nighttime. But now it's changing. A lot of mirrorless cameras are now capable of doing excellent night sky photography, such as Nikon Z6 series, Canon EOS R series, especially the RA made for astrophotography. The Sony A7S has now 3 different versions. The last version is remarkably good for night sky photography. So it's a combination of all of that. The DSLRs are pretty good in night sky photography too. So the answer is both at the moment. But look for full frame cameras. If your budget is below a brand new full frame camera, look for a used full frame camera instead of a brand new crop sensor. That's my recommendation for low light photography. You need a larger pixel size on the sensor, individual pixels. And if you use a crop sensor, that means the sensor is smaller. Each individual pixel is smaller too. So look for a full frame camera, preferably not very high megapixel. If the camera is 40-50 megapixel, this is a great camera for daytime and sharpness and many other things, but not necessarily for low light photography. So something in the range of 20 to 30 megapixel is usually better. So that's one side. So the brand is not that important. All of these major brands are doing fine. A lens is very important because you need a fast lens. I personally use many of the Sigma Art lenses because they're fast, they're a bit more affordable than other companies, and they're very sharp at wide open aperture. So that's the reason it has been my mainstream lenses in the past few years. And then comes a steady tripod. You have to rely on your tripod at nighttime. Do not invest on cheap, very portable tripods, very light ones. Because we have seen it during our photography workshops that the camera equipment is fallen, of course, broken, unfortunately, because of cheap tripod use in a windy location. And speaking of software, I usually import all the images as RAW file. You have to shoot in RAW, of course, in Adobe Camera Raw. So it's a plugin that comes freely with Photoshop. it's equivalent to Lightroom. The back engine of these two are very similar, but they're just different places. The functions are sorted differently. Otherwise, whatever you have in camera is available in Lightroom too. Lightroom has some extra things for cataloging. If you catalog your images through these systems, highly recommended. I don't use it because I catalog it by other folders and just simple ways. So instead of using Lightroom, I use Camera because it's faster. It's getting less memory from the computer, and it's easier to handle. After it's done in the camera with some exposure compensation, shadow recovery, highlight recovery, some radial filter, for example, gradual filter, you have to limit yourself because otherwise you will invest the whole day on a picture and the result is much worse than the first few minutes. So you have to satisfy after a while that, okay, this was the natural result I could get from the picture and it's done. You might end up opening up in Photoshop if there is something else to recover. Most often I don't do that. If you want to combine the images in order to create a panorama, I can stitch them inside Lightroom or Camera. They have the possibility, or use a dedicated software for panorama stitching, such as PTGUI, PTGUI. I also have, I think, one of my main webinars on my website is about panorama stitching, and another one is about processing. So you can find a lot more information on those. Yeah, that's it about. And I also like to repeat that in order to stack images for star trails, there are freeware, easy software such as Star Stacks with X at the end.
Okay, then I have an interesting question because you are a TWAN member, and some people is asking how to get, if they want to be a TWAN member, what do they have to do?
Well, yeah, well, at the moment, we have not introduced any new member in the past couple of years because we're changing the platform, we're changing the initiative a bit for a long-term future of TWAN and the website as well. But we are going to announce that as soon as the website is coming, the new one. We are changing TWAN website after 13 years. We kept the record of one of the oldest looking websites in the world, but it's still working. So we are changing it to a new one. The new members, our priority is that you bring a new style, new creativity to the projects. You bring a new territory, area that we don't have a member. So that's very important. And also one of the top priority is to have more female photographers in TWAN. So these are the 3 top ones. So I can tell you that the first new people who are going to be announced in TWAN, at least the first 2 ones, will be female. Each year we add 1 or 2 new members. Generally, we have very little resources in order to handle this project, so it's a very small elite group of night sky photographers, and it's going to gradually increase, especially in areas where we don't have a member. We don't have a member in Africa. So that's very important to have, for example.
And also your preferences on star trackers. You mentioned Polari, but is there any other that you'd like to mention?
Yeah, sure. Well, there are many options. For small ones, the one I use is Polari because it's very reliable in long term. Skywatcher has another one called Star Adventure. Ioptron has another one. These are very similar. Then comes a bit higher quality ones like AstroTrack by a company in the UK, and that can handle very large optics as well. Polari by Vixen has a brand new version which can communicate with the camera, can control the camera as well. So that's a new generation. I was looking forward to it. I have received a test sample of it, and I think it's out there already in Asia and will be out in Europe and US pretty soon in this month or the next Polaris second version, which has also a different design for the polariscope. On larger scale, you're going to have a tracking mount which is built for a telescope, and there are many of those. Just look for equatorial mounts. General companies are like Skywatcher, Celestron, Wixen. These are companies making equatorial mounts for telescope. But for smaller ones, the ones I listed you earlier are the most common.
Okay, there are some people that wants you to repeat several a part of the talk, but perhaps people don't know that this is being recorded and it's going to be on YouTube. So it's on the same website that you have registered. You can access the link for this webinar actually from tomorrow. So if you want to see it again, it'll be available pretty soon. So I think that's about it, Babak. The rest of the questions you've actually have answered already. It is always a pleasure. We couldn't have you this May because of the pandemic, but we will have you next year, I'm pretty sure. And it's very quiet here, really nice for us photographers, so we can enjoy without people around. But I'm sure you want to come. Thank you very much.
I have La Palma already, yes.
Yeah. Okay. Thank you, Babak. It was a pleasure.
All the best.